Hello and welcome. In this video, we're going to take one last look at our problem underscore 01 and problem underscore 02. Those were the problems that we used to demonstrate the flaky customer, the need for the software design process, software design method, and our top-down design approach. If you recall from the first problem and the second problem, that basically our requirements changed significantly enough that we ultimately broke up the problem into multiple smaller functions. Now, this video assumes that you've already got that working, that you followed along with those videos, and that you, if anything, already understand or can appreciate the need for the top-down design that I showed you in a graphical way and have tested your application. You can see here on the screen that basically I've demonstrated that it does, in fact, work. But if you recall, we had an annoying little problem here that every time we wanted to turn on and off one of these demonstrations, basically we commented or uncommented one of the lines of code out, and we had to rebuild our executable, which that's rather annoying, and it also limits us as to what we can do significantly. So what I'd like to do in this video, and this won't be the only time that you get to see this, is I'd like to show you a way in which you can control the behavior of your executable by passing a command line argument. Now, it turns out there's a couple of ways that you can control the behavior of your application. We could actually collect some input from the user and have more of a menu-driven approach, but this one's kind of a little more automated, where we pass switches to the executable. This is going to be really your first exposure of how to do that. If you've already followed along a little bit with the fundamentals demo, then you know where we're going with this. And if anything, I'm just going to show you how to integrate these examples into the fundamentals demo. So the first thing that you want to do is you want to declare a new variable called index, and it is going to be of type integer. And the idea here is that we're going to use this to ultimately loop through all of the arguments that are passed on the command line. Now, I realize I'm throwing a lot at you, and you may not have had a chance to watch all of the videos associated with that, but effectively what I'm trying to do is get you a primer for how we're going to do things in the future. The other thing I'm about to throw at you is a new structure that we have yet to see. We've seen how to do functions, but we haven't seen how to do any sort of flow control. And so what I'd like to do is I'd like to simply loop through each of the arguments that have been passed to the executable and simply prove that we can actually display them and understand what they are. The first thing that we're going to do, however, is we're simply going to display the count of the arguments. And we do that using a printf count and %d. The %d placeholder indicates that we're expected to pass an integer. And if you notice, our argc is in fact an integer. Now, what you call this, whether you call this argc or count, doesn't really matter to me. In different videos, I use different variable names or different prompts. Again, perfectly fine. And then what we want to do is we want to start off with a for loop with the value of the for loop starting off at 0 and increasing until it reaches but does not equal the value for argc. And what we're going to see is that there is an argument count that includes the executable name, so you will always have at least one argument in a C application. And then we increment the index, and as you'll see when we deal with for loops formally, there's all sorts of ways in which we can increment the index. I'm going to use the shorthand notation, and I've actually provided this to you in a couple of other videos and some templates. So again, if the syntax is a little uncomfortable, don't worry too much about it. Then what we're going to do is inside the for loop, we're simply going to print out each of the arguments. And I'm going to, again, follow that pattern of using these variable names. The argv is essentially all of the arguments. I'm going to use a placeholder for %d to indicate the argument index that I'm interested in, and then a %s, which is going to be for a string. So the %d is for an integer, %s is for a string. And for that first placeholder, we're simply going to insert the index. So as the for loop runs, it's just going to put the value of the index into that %d. And then for that second one, we're going to access the individual elements in our argv using our index variable. Now, again, you probably have not yet seen this in C unless you jumped around in some of the videos, but essentially what we would be doing is accessing elements in an array, much like what you would do in other languages. In C, we simply use the square brackets, whereas some other languages use parentheses. At this point, what we've got is we've got the ability now to simply check to see what command line arguments are being passed. Now, temporarily, what I'm going to do is I'm going to turn off both our problem _01 and _02 because I don't want to test those necessarily. But I'm going to build that, and sure enough, it does work. I'm going to go ahead and clear my command window, and I'm just simply going to rerun my fundamentals demo, and you can see that I have one argument, and that argument happens to be the name of the executable. And I'm just going to put something afterwards, literally the word something, and sure enough, it becomes another argument. And then if I do something else, this time with double quotes, well, I get 3 arguments, and you can tell from there that I can pass multiple arguments, including arguments with spaces, as long as I use double quotes around the argument. Now, where are we going with this? Well, the idea is I would somehow like to be able to call problem _1 and effectively call only that function, and then also pass the argument problem _02, and sure enough, be able to call only that function. Well, it turns out that's actually pretty straightforward in that what we'll do is we'll keep an eye on this argv square brackets 1, and we're going to leverage the argument count. And we can do that by simply using an if statement. And so what we'll do is we'll check to see if our argument count, or argc, is equal to 2. And we're going to use a new function called string compare I that allows for us to compare 2 strings, and it will return a -0 or 1 depending on how those strings relate to each other. Now, for right now, we're going to keep it simple, and we're going to look to see if they're equal to each other. We're going to return a 0, so we're going to use a string compare I. We're going to check that argv square brackets 1, in other words, the argument that comes right after the executable. And if it matches the /problem _01, and that value is equal to 0, well, what we'd like to do is we'd simply like to call our problem _01. And then we follow this up with another else if. Again, what we're going to do is we're going to check to see if our argument count is equal to 2. And again, what we're going to do is we're going to use our string compare I. Again, what I'm doing is I'm just hitting control in the space bar to help me auto-complete a little faster. And we're going to check to see what that second argument is, that argv square brackets 1. Remember that C is 0 based in its arrays. We're going to look at that second argument, and if it matches problem _02, in other words, if you compare those and you get 0, well, we're going to simply call problem 02. And if there's an else, well, the logical thing to do would be to call help. And we'll see how to do that in just a second. But now what this gets us is the ability to control the behavior of our executable from the command line. So if we build this real quick, we come back out here to our command line, and what I'm going to do is I'll make a quick change here where I'm passing, instead of problem _1, I'm going to put a /problem _1. Truthfully, the slash doesn't really matter. It's just sort of a convention, and you'll see many applications use that. But you'll notice that now I'm being prompted for a length, a width, and a height. And notice that we get the table from our first problem. If I change it to problem _02, enter a length, enter a width, enter a height, now I'm being prompted for the radius, bulk volume, and the efficiency, and that's essentially the table from our second problem. And so just by passing that argument after the executable and handling it in this if statement allows for us to control the behavior of our executable. Now, I said that it'd be nice for us to have help. Well, I've provided you with a little snip of code here, which I encourage you to go ahead and start using. If you've already been following along with fundamentals demo, you've got this. But if not, we can go through how to integrate this. You simply copy over the function signature, add it to your ever-growing list of function signatures, copy over this little function stub that I've given you. I encourage you to keep this closer to main rather than at the bottom of your executable, because you will be making a lot of changes as we go along. As a matter of fact, why don't we go ahead and make some changes real quick? I'm going to go ahead and bring this in just a little bit so we can see this on one screen and do a little bit of creative copying and pasting here. And what we're going to do is we're going to add support for our problem _1, problem _2, and you could argue very successfully that this is probably the world's worst help because it's just redundant in what it tells you it's doing. But again, you have the opportunity to improve on this. You can make the help as useful as you want it to be. And then simply under the else, you make a call to your help function. And if you notice also too, we mentioned this in an earlier video when I was talking about top-down design, that our functions, our help functions generally accept no arguments and return no arguments. If we build this, and if we run this, perhaps with no switch, we get help. With some nonsense, we get help. And from there, we can control then the behavior of our application further, in that we can call help if the user does something we do not expect. Now, obviously, we need to clean this up a little bit, maybe tab this over. We can make a few more suggestions that I'll cover in later videos. But this gets you on the path of having a nice, fully functioning executable with a lot of these demos now built in. And more importantly, you don't have to recompile it every time you just simply want to see a different feature. And at this point, you can see there's our help. And then also we can make a call once again to our problem 01 just to make sure that it does in fact work. 1 for the length, 1 for the width, 1 for the height, and there you go. Now, hopefully you found this video useful. Don't worry if this was a little overwhelming and a little fast, because I do cover this in many, many, many other videos. This was just intended to sort of give you a little bit of a primer on how to do this, but also if you've already done the fundamentals demo and just getting started with the switches, this shows you how to fully integrate these examples into the fundamentals demo series. As always, if you have any questions, comments, or concerns, don't hesitate to reach out to me, and thank you for watching.